Hello, my name is Muhammad Salau, and I am from Harmony Schools. And the name of our project is Newton's Cradle. Allow me to give you a little briefing on my project, Newton's Cradle. Newton's Cradle received its origin from its creator, Sir Isaac Newton, and it demonstrates conservation of momentum and energy with 5 spherical balls, also known as executive ball clickers, that are attached to a frame with a wire and swing back and forth like this. Whenever one end is lifted and released, the resulting force travels through the line and pushes the last one upward. Allow me to get into the physics here and explain what goes on when one ball hits another. Momentum, mass times velocity, and kinetic energy, 0.5 times mass times velocity squared, can be used to find the resulting velocity of 2 colliding elastic balls. When all the balls weigh the same, the solution for a colliding pair is that the moving ball stops relative to the stationary one, and the stationary one picks up all the others' velocity, and therefore all the momentum and energy, assuming no friction, no heat, or sound energy losses. Basically, what all that means is that whenever you pick up one ball like this, and it hits another one, all of the velocity that's coming from this one is going to travel through the line and hit this one, which is why it's still bouncing. You see, I'm going to try 2 right now, and you see the other 2 at the end because the amount of force that's coming down is coming down from 2 balls, and it's going to go to the other 2 balls. No. See, that one in the middle stays stationary because there's only 2 balls being thrown, not 3. And let's try 3 right now, but only 2 are going to go because one of them have to stay, obviously. You understand that now? Okay, I was once asked, how does conservation of momentum affect our history and how is it used in our everyday life? Therefore, I gave an example of how cars are an example of conservation of momentum. I explained how when we are in cars and we slam on the brake, everything inside of the car goes flying forward. Why? Because it does not match the amount of force, velocity that's being applied when the person slams on the brakes. And I was once told to write a personal experience with conservation of momentum. So I wrote a series of short stories and how I came in contact with conservation of momentum. Which stories is on how I got into a car accident and how I ran into this one girl and she went flying backwards. The pool games. Well, this has been a very long script, so I'm going to sign off by saying goodbye and visit our Harmony website, Facebook page, or YouTube channel for more info. Bye.